Hi class, it's Mrs. Kane. I'm back with your next e-learning video. I want to start by saying thank you to those that are still watching the videos. I know in this time of uncertainty, it's hard to keep your motivation to do schoolwork, especially as seniors. So I appreciate those of you that are still watching. I'm going to keep making them, even if it's only for a few of you that are invested in your learning. All right, so our next topic is going to be solving equations with exponents. And so we're going to start by reviewing how to solve quadratics, which we learned back in Unit 5, solving quadratics by square roots. And then we're going to use kind of a very similar method to solve equations that have higher exponents. So quick review from Unit 5. If I asked you to solve this first equation, the first thing we want to do is get the x squared by itself. So we're going to start by adding 8 to both sides. And we get 2x squared equals 32. And then we can divide both sides by 2. And so x squared is 16. Okay, and then here you can use mental math, or you can kind of take the square root of both sides. Okay, but you're looking for a number that you square to get 16. Okay, so 4 squared is 16, and these are the problems where we also recognized that negative 4 squared is 16. And so the shortcut is to use a plus or minus sign. Okay, the next problem, x minus 3 squared equals 81. So think about that base. You're going to square it to get 81. So that base, x minus 3, could equal 9, or the base, x minus 3, could equal negative 9. So if x minus 3 is 9, we're going to add 3 to both sides, and we get x equals 12. And then over here, if we add 3 to both sides, negative 9 plus 3, we get x equals negative 6. Okay, and so your answers are x equals 12 and x equals negative 6. So remember, when you're solving by taking an even root, we need 2 answers. Okay, so today we're going to learn how to solve equations that have higher degrees. Okay, we're going to use very similar steps, but instead of taking a square root of both sides, we might have to take a cubed root or a fourth root or even a fifth root. Okay, and the key is that if you have an even exponent and you're going to take an even root, that is when you have to remember to use the plus or minus sign. All right, so let's go ahead and take a look at a couple of these. So the first problem, we have an x to the 5th that we're going to try to get by itself. So we're going to go ahead and subtract 7 from both sides. 3x to the 5th equals 96. Divide both sides by 3. X to the 5th equals 32. Okay, now right here, we're trying to get rid of that 5. So instead of taking the square root of both sides, we're actually going to take the 5th root of both sides. Okay, and you can use a calculator to do this. Okay, most calculators have a button that looks like this. Okay, so if you put 5 on your screen, so hit the number 5, and then select this button if you're using a scientific calculator, and then you can go ahead and type in the 32 and hit enter, and it will tell you that the 5th root of 5 is 2. Okay, so these are kind of your calculator steps. On a scientific calculator, this should do the trick. You might have to hit the second button to access those keys. Okay, now, because we took an odd root, we took the 5th root, we do not want to use a plus or minus sign. Okay, 2 to the 5th is 32, but negative 2 to the 5th does not equal 32. It equals negative 32. Okay, now the next problem. Okay, we're going to try to get this base here, x minus 3 to the 4th by itself. So we have to undo this multiplication. So we're going to start by dividing both sides by negative 2. We're left with x minus 3 to the 4th equals 16. So we have the base by itself. The base is x minus 3. Okay, so we're trying to get rid of this 4. So from here, we're going to take the 4th root of both sides. Okay, when we take the 4th root, it just cancels out the exponent. Those two operations undo each other. So we're going to write x minus 2 equals. Okay, and then on the calculator, if you take the 4th root of 16, you should get 2. Okay, but notice that you're raising that to the 4th power to get 16. So that base could be 2, or that base could be negative 2. And so we say x minus 3 equals 2, or x minus 3 equals negative 2. Okay, so if I add 3 here, I get x equals 5. And if I add 3 here, I get x equals 1. So because we are taking the even root, we do need to include a plus or minus sign, and so we end up with two answers, x equals 5 and x equals 1. All right, so if those problems made sense, go ahead and pause the video and try the next two problems. If you're not quite there yet, just stay with me and I'll go through a couple more of these. All right, so the next problem, we have 2x cubed minus 4 equals 50. Okay, so the first thing we're going to do is get that x cubed by itself, so we're going to add 4 to both sides. Okay, then divide by 2, so we have x cubed equals 27. All right, and now we're trying to get rid of that 3, so we're going to take the cube root of both sides. Okay, and again, you can use a calculator here. You're going to put on the calculator, just type 3, and then you're going to find that button that looks like this, and then you're going to put a 27. Okay, so you get x equals 3. Now notice we're taking the odd root, so we do not need a plus or minus sign here, so we just get x equals 3. All right, for the next one, we have x minus 3 to the 4th minus 1 equals 80. So we got to start by adding 1 to both sides. So we have x minus 3 to the 4th equals 81. Okay, and x minus 3, that's the entire base. So right here, we got to take the 4th root of both sides, and that will allow us to get rid of the 4 here. We're left with x minus 3 equals, okay, we're going to raise that base to the 4th power to get 81. So that base could be positive 3, or that base could be negative 3. And I'm getting the 3 because the 4th root of 81 equals 3. Okay, so I'm going to add 3 to both sides. Okay, so one of my answers is 6, and then over here I get x equals 0. Okay, so again, the key is if you have an odd root, you're going to get one answer. If you have an even root, you're going to get two answers. Okay, so the last type of problem we're going to talk about today is solving equations that have a rational exponent. So that means the exponent has a fraction. Okay, so we're still going to isolate that base that has the exponent, and then to get rid of the rational exponent, the fraction, we're going to multiply the exponent by its reciprocal. Okay, so let's go ahead and try one. So for this first one, I'm going to add 4 to both sides. 2x to the 1/2 equals 8. And then I'm going to divide both sides by 2. So I get x to the 1/2 equals 4. Okay, so now I have to try to get rid of this 1/2 as my exponent. Okay, so right here, what can I multiply 1/2 by to get just 1? Okay, so I'm going to raise both sides. I want to raise this to the 2nd power. Okay, so if I raise that to the 2nd power, 1/2 of 2 is just 1, and so I just get x. Okay, so 4 squared is 16, so we just get x equals 16. All right, next problem. I'm going to add 2 to both sides. 3x to the 1/3 equals 6. I'm going to divide both sides by 3. So x to the 1/3 equals 2. And now again, I need to get rid of that 1/3. So I need to raise the left side to the 3rd power. Whatever I do to the left, I have to do to the right. 1/3 of 3 is 1, so I just get x equals, and then 2 to the 3rd is 8. Okay. All right, so the last two problems, you'll notice that we have a number on top. So now we have a numerator. So we're still going to be multiplying by the reciprocal, but we're going to have one extra step at the end. All right, so let's go ahead and get this x to the 3/2 by itself. So I'm going to add 1. 2x to the 3/2 equals 128. And then I have to divide both sides by 2. So x to the 3/2 equals 64. Okay, so now you got to think of the reciprocal of 3/2, which is 2/3. Okay, so whatever I do to the left, I have to do to the right. Okay, now we're going to make a connection to yesterday's video. So right here, we're going to write this 64 to the 2/3 power. We're going to change that to the cubed root of 64, and then we're going to square that. Okay, so you can put the cubed root of 64 in your calculator. You should get 4. and then 4 squared is 16, and so the answer is 16. Okay, and notice to solve, we took an odd root, so we do not need a plus or minus sign. All right, and then the last problem, we add 2 to both sides here. We get 3x to the 2/3 equals 12. Okay, then we are going to divide both sides by 3. And so x to the 2/3 equals 4. Then we have to multiply by the reciprocal of 2/3, which is 3/2. Okay, so now we have x equals, let's change this to radical form. So we have the square root of 4, and we're going to take that answer and cube it. Okay, so the square root of 4 is 2, and then 2 to the 3rd equals 8. Now what you have to be careful of right here is we took an even root. Okay, so when you solve by taking an even root, okay, we have to say that x could be 2 cubed or it could be negative 2 cubed. Okay, I know that's a little tricky, so just do the best you can to understand that. Okay, so anytime you're solving by taking an even root, you got to consider that that base could be positive or it could be negative. Okay? All right, so that's all I got for today. I'm gonna post an assignment to go with this. It's just gonna be 4 problems, 2 of each type that I taught today. So if you can go ahead and try those problems, check your answers. I will post a key and then go ahead and submit it. That would be great. Tomorrow will be an Alex Day, so you won't have a video lesson. We'll pick up on this with this stuff on Monday.